So by carefully observing the sparks, we were able to determine that this is negative, that is positive. Since the sparks were jumping this gap, which is approximately 20 centimeters, if the air in this room is insulating to 1,000 volts a centimeter, that was a 20,000 volt spark. Very hard to determine with air because my presence here is changing the humidity of the situation. But that's a rough idea of how you can get an idea the kind of voltages we're dealing with. Now what I want you to pay attention to is the brightness of the spark as I vary the distance between the sphere and the discharge sphere and the large one. What effect did you notice? Several things I noticed. As I got in closer, the bolts got more concentrated. They were finding a cleaner path from the negative to the positive. As I got further away, they didn't so much get brighter as they got bigger. So let's watch that again. Very straight, clean path. And as I back away, and if I get too far, I take the shot across the face like that. What I can tell you is it hurts more to go further back. It's no difficulty at all there, no discomfort at all, but that starts to hurt a whole lot more. And you can see, can't even hold my arm still, how much more intense it is at a distance. Why is that? Why is it easier to bring your hand to this close than further away? What's special about the air that's causing the bolts to get bigger if you put a larger gap between you and the sphere? Why is there no perceptible electricity here, but as I move further away, use my knuckles because they're less sensitive. As I go further away, the bolts get bigger and progressively more painful. It has to do with what I said at the beginning. If air is insulating 1,000 volts a centimeter, and we have 20 centimeters between my arm and the Van de Graaff, it will only discharge when it reaches 20,000 volts. If I have my finger a centimeter from the large globe, then a voltage of only 1,000 will jump the gap. So in other words, when you want to approach a Van de Graaff and not get a colossal shock, you go in quick. Then the electrons can jump to your hand. I know this is the positive dome, but it's easier to phrase it this way. The charge can leap to your finger before it builds up a larger voltage. So the trick is not to do this. Not to go in fearful, you get the big shocks. Go right in really close, and now you're getting very low voltage shocks. And the further out you go, you can even hear how much more intense they are before they can make the leap. So that's the second effect. The brightness of the sparks is dependent on the distance the arc has to jump. So go in close if you don't want a big shock.